work, power and energy. We'll concentrate on work. Work term in general has a wide meaning, but when you talk in physics, work means always the external work. You go on standing at a particular place, you will be tired, there will be fatigue, and you would say, I am tired. Actually, you are tired. You have lost your internal energy, but there is no displacement. Physics is not going to accept this. Physics accepts only that work in which there is displacement. Sometimes it is also known as external work, but in general we call it work only. One has to remember we are dealing with external work which is possible with the displacement. Work is a scalar quantity and this is considered to be the product of force and displacement. Force F and displacement T. See, this angle is theta here. Force has been applied on the block that has been shown blue, and displacement is this way. This is the direction of displacement D. F and D, angle between them is theta. Now you know dot product is AB cos theta. A dot B is AB cos theta. Here also we have F D cos theta. Theta the angle between the two, and that's a very relevant factor. Theta is changeable, that depends on the way you are applying the force. Theta might be 90 giving you cos 90, 0, no work. Theta might be 0, might be 180 degree, depends on your choice. But one very interesting case is when theta is 0 degree, cos theta is maximum, that is plus 1. In that case, the work is going to be maximum. Theta is 180 degree, it will be minimum. And above all, the most interesting case is when theta is 90 degree. Cos theta will be 0. No work will be done. Means when the force and displacement both are perpendicular, no work will be done. You are having some luggage over your head and you are moving horizontally. You are walking this way with some luggage over your head this way. In this case, the weight is acting downward, that's a force, and displacement is this way, horizontal. Weight is this one. Angle between them is 90 degree, no work is done. So if a coolie with luggage over his head is moving on the platform, in the eyes of physics, he is not doing any work against the gravity. He might be doing work against the friction, but as far as this gravity or the luggage is concerned, no work is done. This is one case that's a very prominent, and this is considered in so many examples. Then when force is 0, means there is displacement but no force. For example, you choose a smooth surface, the body is moving and the surface is smooth, there is no friction. For constant speed there, though the displacement is regularly taking place, but no work will be done. And then if the force is regularly there, but displacement is not there, then also no work is done. Suppose some load over the head and you are standing regularly, since there is no displacement, don't even think of work because there is no displacement. So these three cases, F0, displacement 0, or the angle between them is 90 degree. In these three cases, you find that there is no work. Gravitational force does work when somebody is falling freely, and because gravitational force is doing work, energy, kinetic energy will increase. If the body is thrown upward, gravitational force will work against the force, and in that case you might say that the work being done is negative and the kinetic energy will decrease. There are some special units for energy. Very common in SI is joule, but other units, are, this is 10 to the power minus 7 joule. That is, 1 joule is 10 to the power 7 earth. 1 electron volt, this has been taken from the value of electronic charge. This unit is very common in nuclear physics, electron physics, all that. This 1.6 10 to power minus 19 electronic charge. In electricity, while dealing with the units consumed or the electricity consumed in the circuit, most common unit is kWh, that is kilowatt hour, normally known as in public life as unit only. This is kilowatt hour. This would be equal to 3.6 into 10 to the power 6 joule. So these are various units. In heat you find one common unit calorie, that is 4.18 joule. These are various units of energy that we come across in different branches of physics.